So today's lecture is on volume of prisms. And these are notes for 11-7. So even though, and really the volume, and you've done this before in 8th grade, the volume of a rectangular prism is just length times width times height. And if you want to remember this formula, that's fine. But I only teach the one formula for volume. And as we were discussing, if you look at any prism, bless you, you can see here on this triangular prism, that's that first floor. So if we view this as a building, and this is the first floor, and we're taking the area of that first floor, and then we're going to multiply it by all the number of stories in that building, which is that height. So it's just that area of the base, big B, times the height, h, is going to give you that full volume of that prism. Why not view this one the same way? What's the area formula for this base right here?
Length times width.
Right, so isn't this right here, big B times h? So it's still just area of the base times the height. So the nice thing is when they give you the dimensions of a rectangular prism, they give you the length, the width, and the height. You really do just multiply them together. And I don't mind if you use that. But we'll go ahead and look at number 2. So we're going to go ahead and shade in the base, or the bases. So this bottom, and remember on a rectangular prism, you have a choice of 3 different pairs of bases that you want to use. I always like to choose the one that it's sitting on, because then it's easier to see your height. And so the top and the bottom are the bases that we're going to work with, but I really only care about that bottom, so maybe I'll just erase those and just shade in that bottom. Alright, so let's go ahead and apply our formula. All volume formulas for prisms, things that are not pointy. Whoops, got area going there. Let's try volume. Volume is equal to big B times h. So I just have to find big B. So off here to the side, I'm going to find big B. Big B is length times width. For the base that I shaded, we'll let this be, it doesn't matter really which one's length and which one's width. We'll let the 14 be width, because if I trace from the top here to the bottom here, so I'm going to pick this point here to that point there, those are corresponding points on each of the bases. If I trace from base to base, that distance is always the height. That means that this 4.5 represents the height, bless you, the height of the whole prism. So make sure that you know, one of the biggest errors that I'm seeing you guys make is you're not plugging in, identifying the correct things that go into these formulas. So it's one thing to know the formula, that's the first number one important item. But then thing 2 is to be able to identify those pieces from the formula onto that figure. So we're just doing 10 times 14. So isn't big B equal to 140 inches squared? So I've identified my height, I've identified my big B, we can just use the formula. So then step 2 is right here. So big B is 140 squared inches times the height, which is 4.5 inches. Now here's the joy of putting in your units of measure into your figure. What is inches squared times inches? Inches cubed. So we've got 140 times 4.5, which is 630, and then it's inches cubed. Volume is always 3-dimensional. Volume, if something has volume, I can pick it up. I can see it, that's dimension 1. I can touch it, that's dimension 2. I can physically pick it up, that's dimension 3. So volume gives that 3rd dimension, that's why your units of measure are cubed. Alright, so those are the easy ones. And again, as I said, you could have just multiplied 10 times 14 times 4.5 if you want to, but that's just one more thing to memorize. So let's look at all other prisms. So these are kind of weird shape prisms, ones that you tend to have difficulties with. Look at number 4. Discuss with your table partners what is the base of number 4, what shape is the base, and just shade one of them. All right, so what is the base? What are the two bases that are distinctly different, but are the same size, same shape, and are parallel? The triangles. So I'm going to shade the back one because it doesn't have all the stuff on it. So it'll be easier for me to label my things. But you can definitely see that this front right here is parallel to this back here, right? So if I want to find big B, because I know that my volume formula is big B times H, I've got to use my area formula for that triangle. So it's 1/2 base of the triangle times the height of the triangle. The height of the triangle is different than the height of the prism. So on this triangular face, I'm looking for two perpendicular lines. Do you see two perpendicular lines? Because the height and the base are always perpendicular to each other. They're kind of turned sideways, aren't they? Here's one, and here's the other one. Do I know this length here? It's 12. So I can bring that 12 feet down here, right? And then they've labeled this length here as 7.3 feet. There's no right triangle knowledge that I have to apply here. It's just all there for you. So we're ready to go ahead and apply the formula. I have my pieces for big B. So 1/2 times the base of my triangle is the 12 feet. The height of my triangle is 7.3 feet. And then we're just going to use our calculator. So do the 1/2 last. So you're going to do 12 times 7.3, which is 87.6, and then divided by 2. So we get 43.8. Feet times feet is feet squared. Then the next thing you need to do is find the height of the prism, because we've got big B, we need to find H. So as you pick a point, so just pick a point on one of the bases and find its corresponding point on the other base and trace from that point to that point. Wouldn't you agree that these are corresponding points? That represents the height of that prism. Even though it's not sitting on its bases, that's the height of the prism. So what is that distance? 5, because it's parallel to this one here. So that means that this 5 feet here is the height of the overall prism. So now we're ready to apply our volume formula. So step 2, volume is equal to big B times H. There are a couple of you that are still skipping that step. And typically when you're skipping that step, you're getting wrong answers. Because you're not being driven by the formula. You're having to use your brain. And then the height is 5 feet. So my volume is just 43.8 times the 5. Oops, I didn't want that. 43.8 times 5. So we get 219 feet squared times feet. Feet cubed. And there's our answer. So then I would like you to try number 5 on your own. I am going to silently do it up here. Try not to look at it unless you get stuck and you need some help. Okay? So you're doing 5 on your own. When you get an answer, share it with those around you. You can look at what I'm doing. How'd you do? Question. I know. Oh, yeah, I think that's a typo on their part because I just realized that I put the inches here and I'm like, they can't be the same. So that is a typo. I wouldn't expect you to convert inches to millimeters or vice versa. Now, would I expect you to convert inches to feet, feet to inches? Yes. So if it's within the American Standard System, sure. If it's within the metric system, sure. But we're going to take this, oops, we're going to take this and make it millimeters. So good catch. Y'all are paying attention to your units of measure. Nice job.
I didn't even notice.
I was like, I really don't even know how to do
All right, so did we get the correct answer, though? That's the important part.
Yeah.
Okay, so again, if you're not splitting out your big B versus your height and you get the wrong answer, because there are several of you in here, not a lot of you, but several of you, that are putting it into the calculator wrong. I have no idea what you're doing wrong, but if you're not checking your homework, you have no idea that you're making that mistake. Number one. And number two, I can see the mistake is either in here or you chose the wrong height, and then I can award you partial credit, but you've got to show that work. All right, so let's look at the trapezoid. It's still big B times H. It's just the trapezoid's a little bit more difficult of a formula, but it's not a big deal. So would you agree with me that the trapezoid is the base? Okay, so I'm going to shade the back one just because it doesn't have all the stuff on it. So if my area formula, big B, is equal to 1/2 the sum of the bases times the height of the trapezoid, not the height of the prism, I am looking for two perpendicular parts on that trapezoid. Do you see them? Because the height and the bases are perpendicular to each other. So here's one, and here's the other one. So that means that this 17.9 is the height of the trapezoid. And then this 14 meters, we'll let it be B sub 1. What is this distance here? Yeah, bring that 36 over. So 36 will be B sub 2. So we're ready to plug into our formula. So I've got 14, and I'm going to leave out my units of measure just because I'm going to run out of room. And then 36. And then our height is 17.9. So big B, if I add the 14 and the 36, I get 50 times 17.9. I get 895 divided by 2 is 447.5. And then this is going to be meters times meters, which gives us meters squared. Now I just have to find the height of the prism. So discuss with your table mates the height of the prism. I want you to trace from one point on one base to a corresponding point on another base. So find that distance and find the height. Nathan, talk to somebody. Oh, do I have to? Come on, everybody talk. Chat, chat, chat. All right, so let's stop. Tristan, what do you think the height is?
25.
Very good. So if I choose this point to that point, there's your distance between the bases. So I agree that 25 is the overall height of that prism. So we are now ready to use the volume formula. As you can see, there's a lot less work with volume, isn't there?
Oh yeah, this is
Way better, right? So then we've got, right? So, and pretty much you can leave your calculator alone and just kind of do it in pieces on your calculator. You don't have to clear things out either, oftentimes. So we got 447.5 meters squared times the height, which is 25 meters. So multiply by 25, and we get an overall volume that is quite large, 87.5 meters squared times meters cubed. So we good with that? Okay. So let's move to the second page. We're going to do either 7 or 8, and I think I'll do 8 with you because it is the harder one. But let me just point out something on number 7. So would you agree or disagree that on number 7, the triangles are your bases?
Yeah.
Okay, so these are your bases. If I were to find big B, area of that base, don't I need 2 perpendicular lines? So based upon what I see here, wouldn't you agree that these lines are perpendicular?
Yeah.
Well, do I have both of those legs? I have this leg. Do I have this leg?
No.
No, that one's not labeled. But I have the hypotenuse, so I can bring the hypotenuse over, right? How am I going to find this missing leg here? There you go. So you'd have to use some right triangle theory here, Pythagoras theorem. You'd have to use that first to find that. Then that's going to become, and in fact, maybe I'll erase that X and turn it into the base of the triangle. Yeah, and you did.
I can ask him
And I said you might, yep. All right, so then let's look at number 8. So I chose number 8 because what is its base?
The trapezoid.
Yep, the trapezoid. And you tend to find the trapezoid a little bit more difficult. So if we're to find big B on the trapezoid, here's your formula, 1/2 sum of the bases times the height of the trapezoid, not the prism. So let's look at this trapezoid right here, right here. What are our bases? What are the 2 parallel sides? Is the trapezoid sitting on its own base?
Oh, it'd be 25 degrees.
Yeah, these are the 2 parallel sides, so it is not sitting on its own bases either, right? So we know this side because we can bring the 39.4 over. So 39.4 is here. And so this is going to be base sub 1, and this is going to be base sub 2. Then all I need now is my height of the trapezoid. So here's my bases. Is there a perpendicular height going from base to base? Sure there is. There's a right angle right there. Right? Isn't that perpendicular to, let me choose a different color. Aren't these perpendicular to each other? Do I know this right here? No. Okay. So we're going to have to find it. But look here, I know this one. I could bring it here. So we're going to do just a little bit of right triangle knowledge in here. So I'm going to take over to the left. So we're going to use a little space over to the left. I'm going to redraw this trapezoid. So you redraw it too. So there's our trapezoid. We know that the smaller base is 25. And I'm going to leave my units of measure off. And we know the larger base is 39.4. It's hard to see my 3's. 39.4. This is my height. I have to find it. I do know that this slant here is 30.6. Those 3's are sure hard to write. So this is 30.6. Okay. If I drew a right triangle here, wouldn't you agree that these are the same? Okay, so I'm going to label this as H as well. I need to find on this right triangle another side. so that I could use Pythagoras theorem. Do I have the ability to find this piece?
Yes.
Yeah. Is that a... Oh, that's a 9. That's a terrible looking 9. So let's see. Can I even erase it? Nope, not anymore. Okay, so this is 39. So we're going to take 39.4 and subtract that 25. That'll give us that piece here, right? So what is 39.4 minus 25?
14.4.
Okay, so I'm going to put here minus 25. And we got 14.4. Now don't I have two sides to my right triangle here? Now I can find the height of my big B. So we're going to use Pythagoras theorem. A squared plus B squared equals C squared. So what are my A and B?
You don't have to.
X or
Well, the legs are always your A and your B. And you're right, it doesn't matter which is A and which is B. But I'm going to put H squared here plus my 14.4. And we're going to square that, is equal to, oops, yeah, that's right, is equal to 30.6, and I'm going to square that. So let's see what we get. So 14.4 squared, so I get h squared plus 207.36 equals, and then I've got 30.6 squared, 936.36. Now what do we do? Subtract the 207.36 from both sides. I get h squared is equal to 729. And then take the square roots of both sides, and you get a beautiful answer of h equaling 27. And that's 27 what? Centimeters. So now we know the height of our trapezoid. That's the height of the trapezoid. So now we can actually find big B. So big B is equal to 1/2 times the sum of my bases, or my bases are 39.4 plus the 25, which is why it's really handy at this point that we labeled them, because it's been a long time since we looked at that, right? And then the height of my trapezoid is that 27 centimeters that we just found. So now run it through your calculator. You've got 39.4 plus 25 gives you 64.4 times 27, 1,738.8 divided by 2. So we get big B equaling 869.4, and then this is centimeters squared. So that was the only hard part, right? After this, it's easy. Let's find the height of this prism. So talk with your table partners. Find the table partners near you. Talk to them. Find the height of that prism. I'm going to call on somebody who didn't talk to anybody. I hope you know it.
Call me. I didn't talk
All right, Dustin.
Alright,
What is it?
it is 30,400.
No, the height of the prism.
35.
All right, so if you pick a point on one base and go to that corresponding point, that's that distance between the bases. I agree with Dustin. This is the height of the overall prism. So we have enough information to plug into our volume formula. So step 2, volume equals big B times h. So our big B was 869.4 centimeters squared. I'm running out of room, so I'm going to multiply it to our height of 35 centimeters, for an overall volume that's going to be huge,
30,000.
times 35. Oh, it's a nice number though. 30,429 centimeters squared times centimeters. Yep. Oh, gracious. Cancel.
Okay.
Yes, we're good.
Okay.
Like, what did I just touch? Okay. So, as you can see, the big B formulas can be a little bit hairy, but we've been working on that for weeks, right? At least 2 weeks. All right, so let's look at cylinders, and then we'll go to applications. So, cylinders are great. It's still big B times H. What is the area of the base on a cylinder?
Pi r squared.
Pi r squared.
Yeah.
So, it's no different. This right here is big B times the H. It hasn't changed. So I don't learn a different formula for the cylinders. Use the same formula. So, pardon?
Why does it say that?
Because big B is pi r squared. Here's my point. Because you have so many formulas you have to memorize for Arizona merits, right? That let's cut it down to not having to memorize a zillion of them. So this is just one more formula that your brain has to think instead of you deriving it on your own. You're supposed to know what the area of a circle is, right? So when you find big B, you just do pi r squared. And then you plug it into big B times H. So that's what I would do if I were you. All right, so look at number 10. 9 is easy, right? They gave you the radius. Number 10, is number 10 sitting on its base? Yes or no? No. Here's the base right here. Did they give you the radius because big B is pi r squared? Girls, please stop talking. Big B is pi r squared.
Radius.
Did they give you the radius?
No.
No. So this is our diameter. What is our radius? 5.5 meters. Some of you got that wrong on your quiz, by the way. You said it was 6.5 or you said it was 4.5. If you can't divide odd numbers evenly, then you best use your calculator. All right, so then we are going to actually find the exact answer, keeping pi in it. And then if you need to do a decimal answer, you can do that as well. But I work in terms of exact answers. So big B is equal to...
Wait, so are we going to be finding the total volume of pi?
Correct. So what happens is...
So there's no point in doing decimal?
Well, there is if they're asking you to round to the nearest 10th or 100th, right? But
Like
you
in
still
this case,
you still should find your exact answer first, because we don't want... Some of you got some rounding errors on your
The
quiz.
exact answer is easy to get.
Say that again?
The exact answer is easy to get.
Correct. The exact answer is so much easier than the decimal answer.
Yeah.
The
That's what I'm saying.
the problem is some of you are estimating your, like, you would go ahead and do pi times the 5.5 times the 5.5, and then you round that answer, and then you multiply it to the height, and then now you have a rounding error because you rounded in the middle of your calculation. So what I'm asking you to do is not do that. Keep pi in your calculation until the very end. So we're going to plug in this 5.5 meters, and we're going to square that. So all you need to do is square the 5.5. So 5.5 squared is 3025. And so big B is equal to 30.25 pi. Meters squared is meters squared. So that's your big B. Leave pi in there. Then we can apply the volume formula for any non-pointy thing, prism cylinders. So volume is big B times H. Let's find the height of this cylinder. So you're going to trace from base to base. What's the height? That 21. Now it is possible that they could have given you a slanted dimension, which you did on your homework, right? But this just creates a right triangle here, doesn't it? With the diameter, the height, and this diagonal distance. So you could just use Pythagoras' theorem, because they will have given you this, you'll have a way to find that, and you use Pythagoras' theorem to find that height. So it is a possibility. That's the only difficult thing that they could do. Or they could use special right triangle angles 30, 45, 60. So just rely on that prior knowledge. So then our big B, that's equals, is 30.25 pi, and then we have meters squared. I am running out of room. So I'm going to multiply it down here to 21 meters. What's up, George?
It's 30, 45, 60. It just, for special.
Yeah, those are your special angles, 30, 45, and 60. There's only 3 special angles. They're not all in the same triangle. Sorry.
I was confused.
Okay, so I've got 30.25 times 21. So my exact volume is 635.25 pi, because we left pi in there, meters squared times meters
Wait,
cubed.
So we don't have to find the decimal answer?
You might have to. So if they ask me to round to the nearest hundredth, then from here, I would take the 635.25 and multiply it by the pi button on my calculator, and
Well,
then
yeah.
round to whatever they ask me to.
Yeah, I
But,
get that,
you know.
For like this one, you don't want to find it yet? 'Cause, like, I
No,
found it,
you
it's
can.
really over there.
You can.
Alright.
But I like to work with cylinders and cones in terms of their exact answers. Mostly because I don't want you rounding in the middle of the calculation. Okay, so let's look at our applications. Those are the most important problems because they're the reasons why we do what we do. This is, whoopsie, this is a typical Common Core style question. You've got a triangular prism with a cylinder cut out of the middle, right? If I want to find the volume of that, what do?
Wait, what?
You have a triangular prism right here, and they've cored out, they've drilled a hole that looks like a cylinder, right? And they've taken that out. So
Sure.
there's a hole going straight through here.
So are we finding the, what are we
You're finding the volume
The volume
of this.
Yeah, I don't know. Wait, what did you
Isaiah?
When you find the volume of the prism and you subtract.
Okay. Perfect. This is just like those shaded area problems where you had to find the area of the shaded region. Take the area of the whole big outside prism, find the area of that cylinder, and just subtract them. You're going to have what's left over because what did they do? They bored that hole in there and it removed pieces from the volume. So we're going to remove it by subtracting it. So we're going to create our own formula, but you could create your own formula, but we're just going to do it in pieces. So we're going to find the volume of the triangular prism first. So we're going to find big B of the triangular bottom. So here's the deal with that. That's going to require a little bit of an issue. As you look at this triangular bottom here, do you have any perpendicular height to that triangle? What kind of a triangle is this? No, that's not a right triangle. Oh, yeah, it is. There. Oh, phew. It is a right triangle. See, I can hardly see that. Look at, there's the right angle up there. That's really hard to see.
So nice.
Thank goodness. Why am I saying thank goodness?
Because now we can figure out what the
Aren't those the perpendicular sides? Don't they represent the base and the height of that triangle? Great, because otherwise we would have had to cut that isosceles triangle in half and use Pythagoras theorem, and it just gets crazy. So this is going to be a base to the triangle, and this is going to be the height to that triangle. So we're going to find big B is 1/2 base of the triangle times the height of the triangle. So we have 1/2 times the triangular base is 5, and I'm going to leave the units of measure out again for room purposes. And then we have another 5 again. So 5 times 5 is 25, divided by 2 is what? So we got 12.5 centimeters times centimeters is centimeters squared. So that's big B of the triangle. Or the triangular base. What is the height of this prism? Trace from base to base. So 14, and won't that be the height of the cylinder as well? Right? Okay, so we're going to use that height twice. So we're going to find volume. Volume of the triangular prism is equal to big B times h. So this is step 2. So we know that big B is 12.5 centimeters squared times the height, bless you, which is 14 centimeters. So we've got 12.5 times 14. So we get volume of the triangular prism is equal to 175 centimeters cubed. So that's our overall big thing. Now we're going to bore out that hole. So read the problem. It says a cylinder with a 2 centimeter diameter. 2 centimeter diameter. Don't we need the radius for the volume formula, pi r squared? Right? So the radius is what? Oh, let's see. I'm going to use orange. So step 3, the radius would equal 1 centimeter, right? So then big B for the cylinder is still equal to pi r squared, right? So we've got pi. Our radius is 1 centimeter squared. So isn't big B of the cylinder equal to 1 squared is 1 times pi is just pi centimeters squared. Just pi. That's the area of the base of that cylinder. Then we're ready to find the volume of that cylinder. So step 4, volume of the cylinder is still big B times h. So our big B we found was pi, and again I'm leaving the units of, well, maybe I'll put them in there, centimeters squared, times the height, which is 14 centimeters, same height that we used on the triangular prism. So I don't even need my calculator for that. The volume of the cylinder is 14 pi centimeters cubed. So I have the volume of the triangular prism, I have the volume of the cylinder. What do I do with those? We're going to subtract them. So step 5, volume of the prism minus volume of the cylinder equals, prism is 175 centimeters cubed minus 14 pi centimeters cubed. Now, this one we're going to round. We'll round to 2 decimal places. So you're going to just put in your calculator 175 minus your calculator. If it's scientific, no heads are on the desks. All heads are up. If your calculator is scientific, it knows the order of operations. So you can just do 175 minus 14 times pi and hit equals or enters, and it should give you the correct answer. So your correct answer is 131 to 2 decimal places would be 0.02 centimeters cubed. And this is an approximation because we just rounded. So it's a toughie. The last one that we're going to do is number 12. So number 12, you get a picture of Eric's pool at the left. So here's Eric's pool. He plans to fill his pool to a depth of only 4 feet. How tall is his pool?
4.5.
So he's not filling it to the top. He's going to fill it, that's supposed to be jiggly water, so that's at 4 feet, right there. With a garden hose that has an 80 cubic foot per hour flow rate, how many hours will it take to fill the pool? Well, don't we need to know the volume that he's going to put into that pool? If I know the volume of the pool, let's say the volume of the pool is, I don't know, 100 cubic feet. I'm just throwing a number out there. If we knew the volume of the pool, what would we do with the rate? Because this is a rate. It's a cubic foot per hour. I could figure out how long, because, you know, what if I've got to go to run to the grocery store while I'm filling my pool? I don't want to overfill my pool, so I want to know how long I can be gone before my pool overflows. So I can actually figure that out with math. So if I know this, and I know that I have 100 cubic feet of pool to fill, what do I do with this? Nope, I'm not going to subtract them, because I'm not divide it. Wouldn't I take the amount of volume I have in my pool and divide it by my rate? I want to see how many hours, because this is 1 hour. That's the amount of volume that will fill in 1 hour. So here we go. Let's find the volume first. So step 1, volume. So volume is equal to big B times H. So we're going to find our big B. Big B is equal to pi r squared. So what is my radius? Yeah, this is my diameter, so my radius is 13.5 feet. So our big B, we've got pi times 13.5 feet squared. So we're going to square the 13.5 feet. And we get a big B, which is equal to 182.25 pi feet squared. So what is the height of what we're finding?
4.
Yeah, it's not the 4.5, it is the 4, because we're only going up that far, right? So this is going to be your height right here. Your overall height is the 4. So we're ready to solve. So we've got big B, which is 182.25 pi feet squared times our height of 4 feet. So multiply by 4, and we get a beautiful volume of 729 pi feet squared times feet cubed. So this is a volume of the water. So I'm going to put W for water. Then step 2, let's figure out how much time it's going to take. So take that and watch what's going to happen. So if I took 729 pi feet cubed, your units of measure is important to this. I'm going to put it over 1. Then I'm going to multiply this by our rate. Aren't rates fractions? If you're driving your car and you're going 30 miles per hour, isn't that 30 miles over 1 hour? Agreed or disagreed? Per means divided by. So on here, if we can put water in our pool at 80 cubic feet per hour, what goes in the denominator? What follows the per? You're not putting 60 because that would be minutes, because we want to know how many hours. So because they said how many hours here, so we're going to put 80 cubic feet over 1 hour. That's our rate. So you have 80 cubic feet. Oh, wait a minute. I want to get rid of my cubic feet, right? So don't I want cubic feet in the denominator? The rates we can use vice versa. You can flip them. So I want that 80 cubic feet in the bottom, and the reason for that is I want those feet cubes to cancel because I want my answer to be in hours. And so the hour, 1 hour, is going to go in the numerator. And so what happens is the cubic feet cancel, and then all you have to do, and we're going to get a decimal equivalency, so we are going to take the 729 and multiply it by pi, and then we're going to divide by 80. So here's what we get. 729 times pi equals divided by 80. So you get approximately 28.63, and it's hours. So therefore, it will take about 28.63 hours to fill the pool. Do you think I can go to the grocery store?
Oh yeah.
I think it's doable. Do you think I could fill it and go to bed and wake up? Probably. Yeah, I'm thinking I could do that. All right, any questions on that?